Good morning, everybody. I would like to say it's nice to see you all bright and early, but I can't see anybody at all right now, so it's got bright lights in my face. We're going to be talking about Oracle data redaction and how it fails to protect data at the moment. Or actually, not at the moment, because it has been patched, so I will not be dropping Ode at the moment. But before we get there, who am I? My name's David Litchfield. I've been a computer security researcher for 12, 14 years now or so. I've worked with some really cool companies, worked with some really cool people. At Stake, back in the day, NCC, we left to set up NGS software and we were acquired by NCC back in 2008. And since then, Accuvant. I'm now working for a company in Australia called Datacom TSS. And I moved there because, well, TSS is obviously a nice company, but to be honest, it's more for the sharks in Australian waters. I started out in buffer overflow exploitation. That was my forte. I really enjoyed the bits and bytes, but commercially I was sort of driven towards database security. You know, no one seemed to be doing it or doing it very well. And so I basically took a decision that I would get out of the bits and bytes. And, well, to be fair, I still do a lot of bits and bytes because our databases obviously, you know, have buffer overflows in them and stuff. But probably the best bit of work I did was in 2003. I've not really done anything great since then, or what I feel is good, when I wrote the first paper on defeating Microsoft's stack protection and safe SEH. Ever since then, I've not really been writing exploits, really, you know. Well, riding the gravy train, to be just to quote the gentleman in front. To be fair, you know, I gave this presentation at Black Hat a few days ago, and the person was like, yeah, that exploit you were doing there. I was like, whoa, 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 these are not exploits. This is just straight SQL, you know, come on. So I just want to be fair about this. You know, obviously it bypasses security and everything like that, but by today's standard, I would not class these as exploits. I've written a couple of books, the Oracle Hackers Handbook, the Database Hackers Handbook, and some of the Windows exploitation stuff in the Shellcoders Handbook. If you're interested in database security or sharks, you can follow me at dlitchfield on Twitter, or if you want to have an offline conversation, longer conversation, not necessarily in public, I can be contacted at david.litchfield@datacom.com.au. So I want to put some framework around, or a foundation for this talk. At the beginning of this year, Larry Ellison turned around and said, to the best of our knowledge, an Oracle database has not been broken into for a couple of decades by anybody. Well, I know exactly what. So who remembers the Sony PlayStation Network breach in 2011? It was the biggest of its kind to date. That was an Oracle database server. That senior Oracle management did not know that one of their largest customers was breached and it was their Oracle database server is criminal. He should really spend less time on his boat and more concentrating on his software. His CSO, who I'm actually quite friendly with, she's actually a nice person. We just don't necessarily see eye to eye on at a professional level. She said customers should hold their vendors to a very high standard. The only way you can hold your vendor accountable is through your checkbook, your pocketbook. Checkbook is what we would use in the UK. So essentially what she said is we need to be getting on our vendors' cases. If they're not delivering a secure product for us, we need to be voting with our money, basically. We should be buying other products. So standing by those words, I would like to then continue this talk. But I want to give you some background history before we get to the, how we bypass Oracle data redaction and stuff like that. I'll cut to the more interesting stuff. Actually, let's do it from the beginning. So there was a guy a few years ago, about 12, 14 years ago, called RFP. I'm sure everyone in this room remembers RFP. He's still around, but he was one of the greatest researchers of our time. And he did a lot of research into SQL injection. It wasn't called SQL injection at the time. In fact, the term SQL injection was invented by a guy called Chip Andrews, the guy who manages SQLsecurity.com. And people were talking about things like SQL insertion at the time. But anyway, RFP had written these couple of papers, and we had a conversation over email about it. And I was like, I've never really looked at database servers. So it was actually RFP who got me into database server security. And one of my colleagues, Chris Anley, and I were doing a pen test on one of our customers back in Cerberus days. And they had SQL, Microsoft SQL Server. And this was back in the days when SQL Server was trivial to exploit and own. And basically, we came across, discovered some new techniques that allowed us to work out what the back end was doing and come across the data structures and so on. And so I put together a paper called Web Application Disassembly with ODBC error messages. So this was my first venture into the database world, essentially. And then myself, Cesar Serrado, and Chris Anley, we were kicking the hell out of Microsoft SQL Server. I wrote a paper called Threat Profiling SQL Server, and in it I covered a couple of buffer overflows. Who remembers what happened on January the 25th, 2003? Slammer, exactly. So there was a worm, basically, that came out and it exploited a buffer overflow in Microsoft SQL Server. It happened over UDP port 1434. And that was a bug I had discovered and spoken about in 2002 at Black Hat, and said, listen, if you don't patch this, this will be the next big worm. The reason I'm including Microsoft in here is because I don't want to see make it look like I'm just bashing Oracle. I'm bashing database servers generally, okay? Because they should be secure and they're not. Well, they're much better these days. Okay. So anyway, then Larry Ellison turned around and announced his product was unbreakable. And you know, everyone talks about when they heard that John F. Kennedy was assassinated. They remember exactly what they were doing at that time. I remember exactly what I did when I heard Larry Ellison said his product was unbreakable. I looked up from my keyboard and said, what the fuck? So my brother and I spent some time being 24 hours, and we sent Oracle, I think it was about 35 to 40 critical flaws, many of them not requiring a user ID and password to gain full control over the database server. So much for an unbreakable product. So anyway, that led to this ongoing relationship, love-hate relationship I have with Oracle. And some of the more interesting patching stories we've had with Oracle, and I want to, the reason I'm bringing this up is because, as I said, it's sort of setting the scene for where we are today and why the Oracle data redaction stuff is as bad as it is. Yeah, so it's not so much that it can be bypassed, it's more representative of what's going on in the Oracle security world, or their approach to security. So anyway, I just want to give some of this background. So one of the flaws I reported to them essentially was that you could, without a user ID and password, cause the database server to load an arbitrary library, execute an arbitrary function, and pass it arbitrary parameters. Now, the way this operates basically is through external procedures. What happens when you have a PL SQL package, that's sort of like PL SQL is the stuff that extends an Oracle database server, makes SQL programmable. If you want to shell out to the operating system and load a library and call a function or something like that, what happens is the RDBMS connects, I keep on swaying. The RDBMS connects to the TNS listener. Now, the TNS listener is the gateway to all Oracle communications, essentially. So the database connects to the TNS listener and says to the TNS listener, will you load this library for me and execute this function? And the TNS listener says, no, I won't do that, but I know a program that will. So it launches a program called xproc and passes Oracle back, a handle, redirects it to a TCP port, basically, and the Oracle connects to xproc, and then xproc loads the library and executes the function, passing it whatever parameters have been supplied. So I looked at that and thought, well, that, there's no authentication going on in there, so what happens if I pretend to be the RDBMS from across the other side of the network and say to the TNS listener, will you load this library for me and execute this function, passing it these parameters? And of course, TNS listener goes, no, I don't do that, but I know a program that will. So lo and behold, xproc loads the library, in this case libc or msvcrt.dll in the case of Windows, executes the system function for me and executes an operating system command without a username and password. So, and across the network. So that's pretty bad. So I reported this to Oracle, of course, because I'm one of these people who, when I find a bug, I don't sit and I report it straight to the vendor. I'm quite happy for people to sit on their ODs, but let's be honest about it. You work in computer insecurity in that case, not computer security, just a fine distinction. So I report my bugs to the vendors when I find them, and so Oracle said, yeah, okay, but we're going to fix this. And what they do now, or did at the time, was basically turned around and said, if someone attempts to do this, we'll block it, but we'll log it, which is good, because we want to see if someone's attempting to attack us. But the problem is they call sprintf on the name of the library. They specify it to a buffer, and I was like, oh, crumbs. So I can hear people laughing already. The C programmers here know exactly what's going on. There's a stack-based buffer overflow with the sprintf call. So I was like, Oracle, we can still exploit this without a username and password. We just exploit this buffer overflow and gain control of the path of execution. And they were like, oh yeah, we'll fix that. So what we'll do, this is Oracle speaking here, I'm paraphrasing of course, we'll put a length check in before we call sprintf. Why they didn't say snprintf, I don't know, but they decided to do the length check. But between doing that length check and calling sprintf, they expand environment variables. That's in between, remember. So if I say $path, that is expanded after the length check, so that's 5 characters, and that expands into however many characters the path environment variable is. So suddenly we, have the ability to exploit this buffer overflow again. So they should have just done snprintf, 256 bytes max, blah, 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 we're done. But no, they didn't do that. So this was, went over a period of years, basically, backwards and forwards, until eventually they fixed all supported versions. Unsupported versions, like Oracle 8.1.7.4, are still vulnerable to this, and there are still people out there. In fact, there's still people out there using Oracle 7. So this was the kind of, approach to patching that, Oracle would take. You would wait 2 years for a patch, and it would be insufficient. And I'll give you another good example of this. So way back when, Oracle Application Server, originally called the Oracle Web Listener, it had this thing called the PL SQL Gateway, and it's a really cool bit of functionality, especially if you wanted to hack into it. Essentially what it does is the PL SQL Gateway allows you to program your web application in PLSQL and have it execute in the database, and the results are passed back via the web server to the browser. And so essentially what happens is the web server takes the user's web request, so if we say get /pls/dad/package.procedure, basically the web server turns around, takes that request, strips out the package.procedure, turns around to the database server and goes, execute that for me and pass me back the results. So of course this is going to be riddled with security flaws, because essentially nothing is being validated and it's just being executed by the database server. So if you knew of a vulnerable package or procedure that allowed you to execute arbitrary SQL, for example. So how many actual Oracle people do we have in here? Show of hands. Who remembers ctxsys.dryload? It was a package that basically had a procedure, validate statement, and what it did was basically, and remember CTXS was a DBA at the time, it validated a statement. You passed it an SQL query and it would execute it. Publicly executable by public, executes with DBA privileges, and so you could say grant DBA to public, and suddenly public is now a DBA essentially. So we could execute this through the Oracle Application Server. We could just go get /pls/dad/ctxsys.dryload.validate statement C buffer equals select star from whatever, or create user, or create a library, whatever we want to do with DBA privileges essentially. So that's pretty bad. So Oracle introduced the PL SQL exclusion list, and on that list are things in the sys schema. Sys is like root, basically. It's the most powerful account on an Oracle system. So anything in the sys schema would be rejected. Anything that starts with DBMS_ would be rejected, because most of the sys stuff has a synonym, and so we can access it without specifying the sys schema. And there's, given that most of the packages start with DBMS_ in the sys schema, they decided to reject that. Anything that started with the OWA_, because the Oracle Web Application Toolkit basically had things like, there was a package called OWA_util, and one of the procedures was cellsprint, and cellsprint took an arbitrary SQL command and presented the results back to you. So this was banned. So it became incumbent upon you, if you wanted to break into an Oracle database server, to execute arbitrary SQL. If you were banned, so things like MDSys and CTXSys were not on the banned list, by the way, from the get-go. So you could still exploit things like the dry load validate statement flaw. And assuming we wanted to execute stuff in the sys schema, though, we had to bypass the PL SQL exclusion list. So having reported this and them introducing the exclusion list, it was now important to bypass the list. And So essentially, the first way of doing it was put a %20 in front of sys, because that obviously, a %20 is a space, and space sys does not match, of course, sys. They're two entirely different things. So it would break the pattern matching, or you could go %0a, a new line character, or %09 for a tab, or 0d for a line feed, and all of these things would bypass the exclusion list. So we could gain everything. Gain access to everything in the sys schema again, for example. So I report this to Oracle. Oracle fixed it, and so on, which is all good. And then during another pen test, we come across an Oracle application server, and they're all patched, and it's brilliant because they're patched. And so we have to bypass the exclusion list again. So this way, the next time was basically using angle brackets. So if you do double angle bracket, that's sort of like a go-to label. So you would request, get slash pls slash dad slash angle bracket, foobar angle bracket, sys dot whatever kind of thing. And again, that would break the pattern matching. So we sent that to Oracle. Oracle fixed it. This is now about year 3. And another time, I'd found a few bugs in the MD-sys schema, and they were like, well, we're not going to fix them because the only risk is through Oracle Application Server. I was like, well, what happens if we find another bypass? And they said, well, we fixed all the bypasses. You're not going to be able to get around it this time. So I was like, well, stuff you guys. Dig. And simple, and it's silly. I should have thought of it from the get-go. More to the point, so should have Oracle. Quotes and quote things. Double quote, sys, double quote. That obviously bypasses the exclusion list as well. So they go ahead and fix that. And eventually, we're now, it's sort of like ping pong or tennis. We're going backwards and forwards. They fix it, I bypass it. They fix it, I bypass it. And eventually, and this is a really funny one. Who knows what the character with the value hex FF looks like? Anyone? It's like a Y with an umlaut on top of it. It looks like a letter Y. And guess what the database server thinks it is? So anyway, the web application server would look at it. You'd go %F, F, S, for sys essentially. The web server would go, well, that is not sys because, it's that FF character, that's not a Y. That's some weird thing. I've never seen that. So pass it through. The database server, depending upon the language packs installed, essentially says, what the hell is this double dot doing on there? I don't think you mean that. Let me strip that off for you and convert it to a Y. So again, you suddenly get access to the sys schema. So eventually Oracle decide that they can't rely on the web developers to do the validation on the web front end. So here's a really smart idea. Let's get the database guys to do the validation. So I'm sorry, I was expecting a laugh there. You're getting the database server to do its own validation, and the thing you wanted to exploit is the database server. So guess what? Their first attempt is vulnerable to SQL injection. So yeah, we're now 6 years into this. So you send this stuff, and you wait 6 months or eight months for them to come back with a suitable patch, and it's just not sufficient enough. They've paid it lip service. Spend some time. We'll move on from there. We'll come back to Oracle patching in a minute. Spend some time looking at DB2 and Infomix. Again, I just want to make it clear that I'm not just bullying at Oracle here. I sent IBM a bunch of bugs, I think about 50 in all. Infomix itself. We'll talk about the common criteria in a minute, and a problem Oracle had with it. But Infomix had a buffer overflow with a long username, so the authentication procedure, you could totally own Infomix. Oracle had the same buffer overflow, long username, and the authentication mechanism. And as I said, we'll come back to common criteria. So as time progresses, you start looking for all these wonderful things, and coming up with new classes of attacks, such as, or new classes of flaws, such as cursor snapping and so on. Lateral SQL injection. But here's the thing. 9 times out of 10, you go and do an assessment for someone, and they've still got weak password management in place. So they don't care about things like lateral SQL injection and stuff like that, or as they've not even got the password stuff right. So it's a bit of a disappointment. So yeah, long story short, I went diving eventually and came back to work. Some more on Oracle patching. So most of the time, they used to fix the flaw. They didn't fix the flaw, they would fix the exploit. So if my exploit had a space in it, because you select star from, sys.user dollar or whatever it happened to be, they would say, well, if the parameter being supplied by the user has a space in it, reject it. Well, hold on, we don't need a space. We could replace a space with forward slash star star forward slash, you know, a comment delimiter kind of thing, you know, and or, you know, a double pipe concatenator. There's a whole number of things. So it was still vulnerable. They hadn't fixed the actual flaw itself, but just, you know, the exploit. So that was typically you know, the kind of response you would get. Or they would use a super secret that no one was supposed to ever know, but of course that's what hackers do, researchers do that. They reverse engineer stuff, and they can get things like secrets, you know. So as long as you knew what that secret was, you would pass that as a parameter and you'd still be able to exploit the flaw, you know, execute arbitrary SQL. You would typically report an issue, and often you would find the same vulnerability in the code 2 lines later that they had neglected to fix, but they fixed the one you'd reported. So again, I just want to stress here that this is, Oracle often take a long time to patch. 2 years you would used to wait for a patch to come out, and it would be broken, severely broken. I do want to point out though that, who remembers the last stages of Delirium, the Polish hacker group? They found a buffer overflow in the iRemote activation interface in DCOM. This is the flaw that Blaster ended up exploiting. Anyone remember that? Or iRemote, it was very nice. Anyway, just, you know, showing that even people like Microsoft, basically, after the whole SDL stuff, they fell vulnerable to this. There was a heap overflow that they forgot to fix. You know, 2 lines of code later, they fixed the stack-based overflow in iRemote activation, but forgot about the heap overflow. So it's not that this is just Oracle doing this, it's the other vendors too. So I want to do some comparisons between Oracle and Microsoft in terms of just the database side of things. So we can see that they're actually getting better. Back in 2004 days, you know, they were patching 28 issues. Each one of these blue blocks represents a flaw that they have called out in their advisories, basically. And so before Q4 2004, they patched things on an ad hoc basis. Now, this was at a time when Microsoft were turning towards Patch Tuesday. And Microsoft was saying, we're having to patch so many things, we need to really get on top of this so our customers can have a recognizable date when they know they're going to have to drop all things and look towards patches. Excuse me. Oracle at the time slagged them off. Oracle were like, oh, that's leaving your customers exposed for a month, you know. Yeah, it says the company waiting 2 years to patch things crappily. And then Oracle themselves now do this. They have 3 months of a quarterly patch update. So after slagging off Microsoft for, you know, doing a monthly patch cycle, Oracle do a 3-month, you know. So I think one of the things that Oracle doesn't like to do is be like schooled by Microsoft, but they really should. And one of the things we'll talk about is SDL, the Security Development Lifecycle. And really, I know Oracle say they've got one, but I see no evidence of it at this stage of the game. And this is what we'll talk about towards the end of the talk. So here is, for all Microsoft SQL Server products, here's the comparison. So this is Oracle 10G, 9i. Remember, eventually that died out, 9.9 and everything like that. So all the way to Oracle 12c. So this is all Oracle's products, and this is all Microsoft SQL Server products. That's a pretty good record, so it sort of shows that SDL is probably working. On the left-hand side of the graph is the days when people like myself, Chris Anley, Cesar Serrado, and so on were you know, weekly kicking the crap out of it, basically. And at that point, Microsoft turned around and said, you know what? Enough is enough. In fact, Bill Gates' trustworthy computing memo was at this time, basically. They were hemorrhaging customers. And what's important here is they took everyone off. This is unheard of in, you know, or at the time was unheard of. They took everyone off the development of Yukon, which was SQL Server 2005, and said, you know what? Let's get back to SQL Server 2000 and do a thorough code review. And the results have paid off, as far as I'm concerned. That's a fantastic graph compared to that one. So even like SQL Server 2005, I think it was a number of years before like some decent bugs were found in it. I think it was Brett Moore from Security Assessment found a couple of overflows and stuff, which was quite cool. And SQL Server 2008, again, there's been so few flaws. And this is, I don't want to talk about IE, because IE doesn't follow this track record so well. But when was the last time you saw a bug in Internet Information Server? Like, yeah, everyone's scratching their heads. When was the last time you saw a decent overflow in Exchange Server? It was a long time ago. They've got the server side down, and it is due to the security development life cycle, as far as I'm concerned. As I said, I don't know what's going on with Internet Explorer. I think they're trying to compete with Firefox and Chrome and something, but those guys are doing really well. You know, the other people, yeah, it's just like, i.e., what's going on? I'm confused. Do they actually work for the same company? Do they read the same documentation? Where are we? Yeah. So this is the background, this is the backdrop to Oracle. And when I retired from the industry in 2010-ish, I went shark diving and decided I'm never coming back, but I'm back, unfortunately. I actually gave them a B+. I was like, yeah, you know, they've almost solved the PL SQL injection problem. So that's pretty good. Their processes are looking much healthier and so on. You know, when they're releasing new products, like when 11G Release 2 came out, I was like, yeah, not bad, not bad. Well done, Oracle, B+. And I go away diving for a couple of years, and I come back and have a wee poke, and I'm like, what the hell? What's going on? They've gone back, reverted to an F. We are going to be looking at something very, very simple, Oracle data redaction. At any stage, these are points from the Microsoft SDL, by the way. If Oracle had an SDL in place, a decent one, any one of these stages would have found and stopped the bugs that I'm about to speak about in their tracks. They would not have breached the public. So establish security and privacy requirements, attack surface analysis, skipping through to the end, conduct a final security review. Okay? That means pen test the product before it goes out the door. Anyone with a modicum of SQL would have found these bugs, as far as I'm concerned. And I think you'll agree with me by the time we get to the end of this talk. So you're going to be really disappointed, because it's like, well, that was bloody lame. Okay, so what is Oracle data redaction? It's a simple, but it's a great idea. So if you have a web app, a database application that has some kind of potentially confidential information in one of the columns, for example, email addresses, passwords, credit cards, whatever it happens to be, you can redact it so what is presented to the user, if they select from that table, is a list of X's or whatever you want to redact it with, essentially. So it's not a bad idea. So we don't actually have to change any application code. We just create a redaction policy on a particular table. And if our web app is vulnerable to SQL injection and someone tries to do a union select star from customers kind of situation, and snarf all the juicy stuff that eventually gets posted on Pastebin, they're not going to get the secret stuff because we've redacted it. So there's no change necessary to our application code, which is I think really cool. The problem is, out the door, so this is in Oracle 12c, and they've backported it to Oracle 11G Release 2. To make it available to those customers. It's trivial to bypass. It failed within the first 5 minutes of simple assessment. So it really speaks to Oracle not pen testing their products before they, in their flagship product, before they go out the door. So let's look at some demos. So before we do anything, I'm going to set up a table called redaction test, and insert a fake credit card number into it, and then we'll commit it. Okay? And now, so if we select it, can everyone see, or do I need to increase the font size? Increase. Come closer. Let me see, properties, font. All right. I'm just going to need to modify the size of the window now. Properties. layout, width, height, wrong way, and 0. Okay. No, I said 0. Windows IS81, let's do that. Okay, perfect. Okay, so if we select from it, select CC, that's the name of the column, we're going to redact an ID from redaction test, that's, you know, we get the credit card. So we don't want the world seeing what that credit card number, so we're going to create a policy on it. And now, if we grant select and update to David, and then connect as David, if we do a select from the redaction test table, we can see, all we get back is a list of X's essentially. So we can't see that data. The data has not been changed. The data is still there. It's just the way it's presented to us has been modified. If I had bypass policy and stuff like that, you know, the redaction policy wouldn't apply to me and I would get to see the stuff. So if I was like a DBA, for example, I can see the data. But I'm not a DBA, so I can't see the data. All I get is the redacted data. So let's get that data out. So there are a couple of XML queries that allow you to run xquery. One of those XML query functions is called XML query. And what it allows you to do is query using xquery, this stuff in the middle, for $I in OraView, DEFCON, redaction test, return I, row, CC. Basically, this is xquery stuff. And we're using SQL and the XML query function. Now, those who do penetration testing and get involved in exploiting SQL injection will understand the importance of functions and concatenating functions. We can execute this XML query to get the redaction, unredacted data back. So you can see there, we are going through a path that they forgot about. You know, as I said, a simple pen test, anyone with an idea of how the Oracle database server works and everything like that would have said, well, hold on, we should probably check XML query to see if, you know, they can bypass redaction. And of course, you can. If you're looking for information like to, you know, monitor and everything like that, the XML table function is also vulnerable. So it's not just sufficient to, you know, protect against XML query. XML table needs to be done as well. As I said, these aren't exploits. Thanks. These aren't exploits. This is just trivial. This is SQL. One of the DML operations, update, in fact, insert has this too, but we'll concentrate on update, has a returning into subclause. And what returning into basically says is, once I update this table, if there's an auto column, for example, a sequence that's, you know, incremented or whatever, return that value to me so I can include it later on in further application code. So this returning into feature, guess what? We don't it doesn't have to be incremented or whatever kind of thing. We can just basically specify return the credit card column information into this buffer and print it to the screen. So there we go. So we can see what's gone on there. We've updated the redaction test column, set the ID to itself, so we've not actually modified any data, but we've essentially returned the credit card column into the buffer and then printed the buffer to the screen. So again, trivial way. Anyone who's done SQL will know the returning into clause. So anyone at Oracle who, I assume they know SQL because they're working at Oracle, would have said, well, actually, let's do a pen test on this product, and we better check for this because no doubt you'll be able to bypass redaction, you know? The where clause, the predicate, is not protected either. So actually, I would like to claim credit for this one, but it turns out that Alexander Kornbrush had already done this when he did his assessment. He noticed that the where predicate was not protected either. So you could pass it to UTL_HTTP you know, .request and send it out to some server somewhere. And there's a couple of other functions that can be used that generate an error and return the data to. Or alternatively, what you can do is simply brute force it. So what we'll do here is create a, sorry, let me Control C. just creating a little procedure here, and let's talk over what it does. We select from the redaction test table the credit card column substring. So we get the first character of the credit card column and convert it to a letter and check if that letter, that number is a 0, a 1, a 2, a 3, or 4, all the way up to 9. Once we find out what that answer is, we then go to the second character, and the third character, and the fourth character. So essentially, we guess it as we go along. So now we've created that procedure, we can simply do, let me set the server output on. Oh, sorry, Control-C. So if we execute that little procedure now, it basically, returns the information. So given that the information, whilst we can't get that information back from the where query, unless of course you're shelling out using UTL, HTTP or something like that, it's just not protected. So it's another thing to be aware of. This, they can't fix it, this in the where clause. The other stuff has all been patched apparently, but this they can't fix because they need to be able to query, do comparisons and stuff in the where clause, in the predicate. So just be aware of that if you are using data redaction. If you have the privileges to execute dbms_redact, you have the privileges to create redaction policies in other people's schemas. You have the privileges to remove redaction policies from other people's schemas. So again, that's another thing you need to be aware of. If you've got privileges on dbms_redact, you have control over everyone, basically. There's a thing called a lateral SQL injection in most databases, and what it essentially does is where there's information coming from, say, environment variables or stuff like that, that's considered obviously trusted for, by the database server. Often the developers will do simple string concatenation, and that may become vulnerable to SQL injection. So, for example, in a couple of years ago, people used to think if it was a number, you could not exploit a numeric SQL injection. You can, because you can specify the number format in a certain way that the comma or the decimal sign is actually a letter. So essentially we can, provided we can create a synonym, we can create a function that eventually is concatenated as a number and be translated into a P01 kind of thing. And that, if we have a function called P01, that gets executed and stuff. So because of developers thinking, well, you can't, if it's a number, how are you going to get arbitrary SQL into a number? There is a way, but they forgot about that. So remember I spoke about PL SQL injection almost being gone, and Oracle doing a good job in that regard. They have left all the numeric SQL injection flaws. So typically the stuff I'm sending them these days is a numeric SQL injection flaw or a PLSQL race condition, which is a whole other ballgame. But anyway, we have to, I've got 5 more minutes for questions and stuff like that, so I'll wrap up there. Just last point, as I said, this is basic stuff. A pen test of the product before it was shipped should have found this stuff, and this really speaks to the Oracle security processes. So going back to what Marianne Davidson said at the beginning, that I spoke about, holding the vendors to a higher standard. Well, this is what we need to do. If you're running Oracle database servers and you don't like the way they're treating you as far as security is concerned, really get on the phone to them and say, come on, I'm going to start buying Sybase or SQL Server or something else instead, because we really need to get this improved. Anyway, so thank you for listening. Are there any questions? Sure.
Have you had a chance to play with the Oracle Vault masking features?
The Oracle which features?
Oracle Vault.
Database Vault. No, I haven't. But I know other people have done. Sorry, Oracle Database Vault. Have I played with the Oracle Database Vault yet? No, I haven't. I know some other people have done some great research in that area, and I just can't think who it was off the top of my head. But if you Google it, you'll find it. But it's on my list to do because I know they've patched a lot of stuff. And the same with Audit Vault as well. There's a whole a couple of bolt-on products, but I suspect it's going to be like the rest of Oracle product. Sure, any other questions? Sure, in the front here.
Yeah, what about views?
I'm sorry?
Does it redact it in a view?
It should do, yeah. You just need to, yeah. Right. I think we'll wrap up there. Thank you, everybody, for attending. I hope it was useful.